Hey everyone, today we're going to learn about simplifying radicals. Before we start simplifying them, first we need to know what a radical is. So here's my little diagram, and we're going to label all the parts. So what makes this a radical is the symbol. So you see that kind of like house shape? That is the radical symbol. Radical symbol. And usually when you have a radical symbol, they're wanting you to find a root. So the root depends all on this little number right here. That n, that's called the index. So depending on what number that is, that's the root that you're looking for. So if it's a 2, we call that a square root. If it's a 3, we call that a cube root, and so on. And then the last thing that I want to show you is whatever is inside of the radical is called the radicand. Okay, so those are the parts of a radical expression. There is one important thing that you need to know, and that is if there is no index given, so if you have the symbol in the radicand, but there's no index here, then just automatically we know that it's a 2. So that's a little bit different than what we've done before. Usually when it's not there, it's a 1. But for radicals, it's automatically a 2. So if I want to simplify a radical, there's 4 steps. The first thing you want to do is find the prime factorization of the radicand. So radicand is, remember, it's what's inside. So you want to find the prime factorization of whatever number that is. Then step 2, you're going to make groups of common numbers inside the radical according to the index. So if your index is a 2, then you're going to make groups of 2. If your index is a 3, you're going to make groups of 3, and so on. Okay, step 3 is you're going to move each group from inside the radical to outside the radical. And then last, you're going to simplify everything by multiplying. So let's take a look at our first example. So I had to kind of write it in because for some reason it didn't come out on my paper. But I have the square root of 72. So you see how it doesn't have an index? Index would usually be out here. So since it doesn't have one, we know that that's an invisible 2. So the first thing we need to do is find the prime factorization of 72. So I'm just going to rewrite that number. And let's split it up. It's even, so I know I can divide it by 2, and that would be 2 times 36. 2's prime, so I'm going to circle it. But 36 I can keep splitting up. That would be 2 times 18. 2's prime, but 18 I can keep going. That's 2 times 9. And then 9, 2's not going to work anymore, but 3 will. So that'll be 3 times 3. So the prime factorization of 72, so I'm going to write it with the radical and everything. So my radical symbol is 2 times 2 times 2 times 3 times 3. Okay, so now that was just step 1. Step 2 says that we're going to make groups of common numbers according to the index. So since index is 2, we're going to make groups of 2, but they have to be the same number. So here's a pair of 2's, and then here's a pair of 3's. Notice that there's a 2 in the middle that I didn't circle because it's not a group of 2. It doesn't have a partner, so I cannot circle it. So the next step is anything that got circled gets to move to the outside of the radical symbol. So those 2's get to move, and those 3's get to move. So a 2 and a 3 on the outside. Then on the inside is that 2 that didn't have a partner. And last step is to simplify everything on the inside and on the outside by multiplying. So I know that 2 times 3 is 6. And then on the inside, that's the only number that was there, so there's nothing to multiply it by. That is going to be our answer, 6 square root of 2. Okay, now let's go on to the next one. I have square root of 216. So just like the one above it, I need to find the prime factorization of 216. So I'm going to rewrite it right here. 216 is an even number, so I know I can divide by 2. That'd be 2 times 108. 2 is prime. Okay, 108 is 2 times 54. 2 is prime. 54 is 2 times 27. 2 is prime. 27 is not even, so I can't do 2 anymore, but I can do 3. 3 times 9. And 3 is prime. And then 9 is 3 times 3. And 3 is prime. So I can rewrite this as the square root of 2 times 2 times 2 times 3 times 3 times 3. I just wrote down all the numbers that I had circled. Okay, so next step says that we're going to make groups of 2 of like numbers. So here's a group of 2 2s and a group of 2 3s. Now I have a 2 and a 3, but I can't put them together because they are not the same number. You can only group them if they're the same number. So now the groups can move to the outside of the radical symbol. So I had a group of 2s and a group of 3s. Then on the inside, the ones that stayed by themselves. So I also had a 2 and a 3. And last step is to simplify everything by multiplying. I know that 2 times 3 is 6, so this would be 6 square root of 6. And that's our answer. The square root of 216 would simplify to 6 square root of 6. And our last example, I have the square root of 196. So first let's find the prime factorization. It's an even number, so I can go by 2. 2 times 98. 98 can be split up as 2 times 49. And 49 can be split up, can't be 2 anymore because that would have to be even. 3, no, doesn't work. It's 7, so it'd be 7 times 7. 7 is prime, so I'm going to circle both of those. So I can go ahead and write this down as the square root of 2 times 2 times 7 times 7. Now we're going to circle our groups depending on our index. Our index was invisible 2, so we're going to circle pairs. So I have a pair of 2s and I have a pair of 7s. So that means that both can go to the outside of the symbol. So a 2 and a 7. Now inside the symbol, there's nothing left because everything moved to the outside. So I don't need to write that symbol anymore. The only thing I need to do now is simplify this. 2 times 7 is 14. And that's our final answer. So this one, the entire symbol just went away. Okay, and that's it. That's how you simplify radicals.